Hey guys, welcome to part 2 of distance formula. Now, in this little lesson here, we're going to just get right to work and do some computing. I have a formula for you. And don't forget, if you're taking notes here, pause the video, take down your notes. You're going to need this formula, so write it down. And we'll do 2 examples. All right, so here's, and look, just so you can see where we've been, the distance formula, you should have written that down with your Pythagorean theorem. Because this distance formula is a result of the Pythagorean theorem. Now, one thing you got to realize here is that when it looks daunting at first, okay? So what this thing's doing, it says the distance formula, the distance between 2 points, x1, y1, and x2, y2, those are ordered pairs, is given by, and it gives us this formula here, d equals the square root, the differences in the x values squared plus the differences in the y values squared. Okay, now it might look messy and things like that, but it's fairly easy to use. But I want to show you something first before we just start plugging this thing into a formula, because I want to show you how to do it both ways. Let me go to this graph I started working on here. Now, write that formula down and follow me to this side, and we can kind of see what they're talking about. All right, so if you've written that formula down, you realize the distance d you're looking for is between 2 ordered pairs. And what we're looking at here, if this is the first ordered pair, and that's the second ordered pair, now they can live anywhere. They're saying the distance is this line segment right here, okay? And what I wanted to show you was, if I was to take and say, well, what if we were to construct, say, a right triangle out of this thing and force it to be a right triangle, then we would have something going on like that right there. All right, now it turns out the difference, if this distance here is 5 along the x-axis and this distance is 2, the difference in those values is x2 minus x1. If this distance along y is 4 and this distance is 1, the difference, or the length of this segment, we can tell is 3. Well, that's y2 minus y1. So you can kind of see how that formula comes about. This is a right triangle, and if we were to take this and square it, add this to square it, we'd have d squared. There's your Pythagorean theorem. Take the square root. So just showing you the theorem comes from Pythagorean theorem. All right? All right, so, and I'm going to use it that way in just a little bit. We're going to do it 2 different ways. Let me get back to the problem I've got for us here for example 1. And example 1 says, all right, now this is a lot like what you'll see. Sometimes, now notice my formula here doesn't have the A and the B in it and all this stuff. Those are just names of the points. Don't let that get to you. That's not a big deal. This is named point A. It's still the ordered pair 1, 1. This is named point B, and it's still the ordered pair 5, 4. All right. Now I'm going to show you how to compute this really quick with the by hand, without any graphing, and it's pretty straightforward. So we'd come in here, and I've already written them down, and right away we'd say, okay, wait a second now. I know that we had D, and that's equal to the square root of a bunch of stuff. Now, I know that's crooked, but it'll just have to be okay. All right, so I'm going to take the difference in my x values, 5 minus 1. I'm going to need to square that. All right, 4 minus 1. There's your y values. You're going to square that. All right, now, 5 minus 1, last time I checked, is 4. Squaring that gives me a 16. 4 minus 1 is 3. Squaring that gives you a 9. And this is the square root of 25, which happens to be 5. So that's how you'd use your distance formula on without any graphing. Now, another way to do this, really quick here, if this thing will work for me, is you could just plug it straight into the calculator. Now this might take a second. I'd have, what was that, 5 minus 1 squared plus See how I'm typing it exactly like it looks. 4 minus 1 squared. Hit enter, and there's that 5. The disadvantage to doing what I just did with the calculator is if they're asking you for exact, a simplified radical, this guy's going to approximate it. So it's got its value, don't get me wrong, it's useful. But it could be done another way. Now I want to show you one more way to do this. Now this requires graph paper, and you guys that have graph paper, you would have it on an exam or anything like that. So that's not to say you wouldn't have it. It can be done really quick with graph paper. Let me just turn all these off and get rid of all this stuff here. And I've already got. I guess I need to get rid of the E and F. And you, get out of here. How do I turn that one off? It's like he's stuck. Alright, so we're looking at A and B. Now what I've already done here is I've already put these ordered pairs on my graph. So one way to do this is you would graph the ordered pairs. Okay? Now, the distance you're looking for is right here. Right? You want to know what that distance is. So, you know, one way to do this is force a right triangle to live here. And then you can block count your way to it. This block has 4 units, 3 units, and then you go directly to your calculator after that, and it would look like this. You'd say, well, I know it's a Pythagorean theorem. Every time I use a Pythagorean theorem, I'm taking a square root. Every time. So you open up a square root, and you know that block count at the bottom there's 4 squared, plus the vertical block count is 3, and we're going to square that, and we're going to get 5. Again, this would not be exact if we got in there and it was an irrational number. We'd probably have to simplify or something like that. But my point is, graph paper and block counting has got its value. It's pretty quick. And you're just using a straightforward Pythagorean theorem. And that other thing just can get messy with signs. Sometimes people mess the signs up. But that's my example 1. I think I'm going to stop this video here. And I'll see you on one more example in the next one. So, see you in just a minute.